Hello and welcome to a brand new episode of Heliopsychosis podcast. Oh, we are having some glitch because of I don't know if it's the internet or it's just getting frozen. Just give me a second. I'm gonna take this out. All right. Hello and welcome to a brand new episode of Heliopsychosis podcast. This is your host Vikka Draziv. Welcome, guys. If you're watching us from YouTube, and please do comment, like, share, and subscribe if you haven't. And if you're watching us from Fern or Heliopsychosis group, do comment and tag your friends. And finally, if you're watching us from realtruthseekers.com or rts.video, welcome, guys. We had an awesome show today. We don't have many guests tonight because a couple of the guests had things to do, so they couldn't make it. And also, last moment time differences also didn't make up to get us together today. So, anyway, I have one of my co-hosts today who's joining me for this special show. You all know him, Genie. Genie, welcome. How are you, brother?
Hey Vika, I'm doing great, brother. Thanks for the introduction. Yep, it's a bummer. A couple of the guys had things pop up last minute, so we'll have a good show. I'm really interested to hear um, what you got to say about this stuff. It's very interesting, and anyone in the audience can really go verify probably anything you're going to say right in front of their own eyes. It's a great one. The moon, the eclipses. How you doing over there? A couple of
Awesome.
glitches earlier in the
Oh
show
yeah.
too. I hope everything runs well tonight, everybody. Yeah.
Yeah, I hope so because sometime it was getting frozen my screen, so I wanted to do screen share, so I hope it don't just get frozen again because I want to show and speak a few things. So yeah, the topic of today is really interesting. The moon, the eclipses. It's mystery. We have so many different views, even with flat earthers, about eclipses and how and what really has been happening. There's so many different ideas and opinions about lunar eclipses. So I'm gonna just play in the background as we speak. So just give me a second.
Sure.
I'm gonna be putting the Chrome. Yes. Okay. Let's see if it. Can you see the screen, guys? Everyone.
I do.
All right. The general conception, the mainstream media, the traditional science. Oh, I'm having an echo. So yes, it's because the Earth is in the middle of the moon and the sun. That's why we are having eclipses. That's the general idea or traditional way that they say always. But there's so many, it's such a different thing that is happening there. So just a minute, I'm getting echoes here. Just give me a second, guys. Sorry for this. All right. So before we just go into what is really happening with the eclipses, we have to understand few other things, So about the moon, does it really illuminate itself, or does it is a reflection of the light of the sun, how the traditional science says, So that's one part that we need to understand. And the second part of the show would be what we need to understand is how the phases of the moon occurs. So that's the second thing. And once we understand these two things, we can really understand what's happening in the eclipse. Okay.
Mm-hmm.
So starting from what do you think about the moon? That does it reflect light or is auto illuminates?
No,
Anybody
it's
wants to ask questions in the chat? Please do. We'll try to also answer anything about the eclipses. Okay, go ahead, Jeannie.
sure. Yeah, everybody in the chat, ask questions, tell us what you know, and I know it's impossible for what happens as we watch the moon to be what they say. It can't be the reflection of the light from the sun. So it lights the moon. The sun is behind the moon, no matter what during the day, and it lights up portions of it. And isn't that impossible? I think that's impossible. And it takes on the color of what's behind it. So at night,
Right, it's
the,
it's not a direct reflection. Yeah, go ahead.
no, it can't be. And you know what? If I'm not, I could be wrong. Vika, maybe but the Terminator line, doesn't move during the night, or does it?
Right,
Like a half moon stays a half moon all night. Is that right? So if that Terminator line doesn't move,
exactly,
then
because it's not in motion. It's
right,
yeah, it's a fixed phase for that
yeah,
day.
right, yes, exactly. So if that's not transitioning slowly, like so, you go back in a half an hour, now it's a little less than a half, or a little more than a half a moon, and then 2 hours later, it's like, oh, but now you can really now look, it's way more than half a moon. So that doesn't happen. Right. So how can that be
Exactly.
the
So
result
yeah,
of three things moving around each other? Come on, I don't understand that. So I'm willing to
right, right.
hear a great explanation.
For example, right now what we are seeing in the image, you could see that the moon it's illuminates that it has its own light. It's like it looks very fluorescent light. It's
Does
not very like the sun has a different light, and the moon you can see it's like actually like a fluorescent. Like have you seen some fluorescent tube or paint how it glows under
hmm
UV light,
sure does, and it leaves a different kind of a
right?
shadow.
So exactly. So yeah,
Yeah.
here what you are seeing is about the shadows, about the moon and everything. I'm just using these images as a background images. What we are discussing have nothing to do with these images, because this video already exists, which
Okay.
explains a bit about the shadow and everything. A
Now this
little different explanation, but also there's a whole video you could just go and watch. But this video I'm just using it for background purposes. What we are discussing here is not the same, but yeah, it's related to the moon and the shadow and the light and the eclipse. Okay,
this is a
so
this is a good one,
if
Vika.
anybody, yeah, go
I've
ahead.
I've done this one. I've done the shadow of a ball on a ball, and it's really nice. It's because the front edge of the ball stretches around and comes out and diffuses, and it's nothing compared to an eclipse. Nothing, zero, nothing like it. It's a really cool experiment anybody could do themselves.
Right, right. So if you want, we can discuss this a little bit, what you are saying too, and then we go to the illumination. But here you can see that it's just showing that the moon is not a sphere. That we don't need to really go to the moon to know the shape of the moon. Like here is showing if the moon is a ball, the shadow should have an S sign wave, and that we don't see like that. We see a whole cut like this, what we see on the
Right,
right.
right, right. Yeah, on the left.
So yeah,
That's right.
yeah, you see the difference in the ball. So
Mm-hmm.
and how the
Beautiful.
shadow falls on different object makes shows have different shadows, or like how we see before here a couple of minutes before, you can see that the shadows are falling different on a curved object. Here you see
Right.
on a stair it's like this. Here is
Look at
different.
that.
On a curve is a different, on a ball is different. So
The ball one I've
so
seen, it's a really good one. Look at it. It takes the shadow takes the
yeah,
shape of what it's. being cast on always.
Right, right. You see, if it's a ball, the shadow should curve, but it's not
That's right.
happening. It's not happening. Not during the eclipses, not during any phases. It's a
Uh,
straight cut. And in itself, it's showing that it's a disc or whatever. At least in its visual form, it's a disc. It's not a
it's not a solid object. I don't think. And how does it? During the day when you see it, um, the dark spots in the moon take on the color of whatever is behind it, like the blue sky or the dark night. So how
right,
does that? You know, I don't know. This might be a little obtuse or weird, but I had a dream about a month ago that I was standing near the moon, and it was like a 3 foot. I was. It's a dream, very strange, but it was just a light. It had no physicality to it. I don't know if it means anything in the real world, um, but I've thought about it a couple times during the last month, and it was an interesting dream. I was just standing there walking through it, and it kind of like two lights were saying hello to each other almost. Like I don't know.
right. Yeah, it's all about the visual and the light. In the end, all what we are seeing above with the sun, the moon, the eclipses, and everything else, it's all
Mm,
light and their differences and their distortions so understanding the light of these two luminaries can help us understand what exactly is happening. As I was saying about the fluorescence, so how the UV light illuminate that fluorescent light because it kind of charges it, that paint or that anything bioluminescence have that potentials to charge itself and
hmm.
illuminate under ultraviolet light.
Okay.
So that's what happening with the moon. So what I mean to say is that the sun is reflecting the light, but what the moon is receiving, it's not the light, it's receiving the radiation, the UV radiation. It's
Okay.
receiving and it's charging. So when it's dark, it illuminates that ultraviolet. So it's the radiation that is illuminating the moon. You
Wow.
you you try like so if okay,
I
the people
follow
can
that.
get it. What I'm trying to say is that we have to understand this, that that's how the moon is illuminating itself. It is illuminating itself, but it still depends on the sun to receive that ultraviolet radiation, like a fluorescent lamps, the fluorescent tubes, the old ones. These are UV, so you see that the old light, they have those box and all this stuff, those
Mm-hmm.
old tubes.
Yeah, big
So these
apparatus too.
fluorescent tubes and all this stuff. Yeah, yeah. It's you see the light is very much like a moonlight. So because the concept is the same. So what happens in the nature, there are many things in the nature that auto illuminates. You have alga, you have insects, you have different kind of fluorescence. You have chemical biofluorescence.
Right.
So the moon one is different. There are minerals, which also there are also plants,
Crystals, if
and
you
there
rub
are
crystals
also
together.
mushrooms. Yeah,
Right. Yeah.
right. And even the caves, you have some. Yeah,
yeah. Fireflies, I guess would count for that.
right. So it's all different kind of luminescence, and one
Yeah.
of this is this, and there's also luminescence that is about the stars. So that is totally different. But yeah, that's the important thing, that it's what we are seeing the moon during the night is is the UV radiation that is charged itself, and in the night it actually illuminates. Okay, so if we understand this good, we could go to the next step, that what's happening with the phases. Okay, So there are in the phases there are parts which are illuminated and there are parts which are not illuminated. To understand that, we have to see the sun and the moon. The sun and the moon has a trajectory above our flat plane, which moves in a cone, in a way up to down in a cone, like a spiral from the north to the to between the tropics. It's not only moving around, but it's moving up and down too. All around the year. You
Is that what
you
causes the
got what I'm
analemma?
saying, Genie?
Right. Is that what helps cause the analemma? The figure 8 over the
Or the
year.
analemma is could be the map of how is it going, but if you see it from another perspective, on a disk, above a disk, the sun and the moon are moving. So they could be. So what happens when the sun and the moon are on the same height,
Mm-hmm.
or if even if they are not on the same height, but if they are 180 degrees, you get a full moon. If
Okay.
you are
Full
if you are
charge.
90 degrees, the sun and the moon to each other, you get a quarter moon. You get what I'm saying, and so on. So depending on which part of the trajectory in relation to each other they are above this circle and their height. So this is what makes
It makes
you get
really
the
good
full moon and the
sense.
quarter moon and the half moon. Okay,
What would you think causes the shape
right?
of it? Instead of, like, let's say, a full moon all the time with the quarter of the luminescence to it versus just a quarter moon with the same luminescence. It makes sense? I wonder what causes the shape.
So what I
Oh, that was in the Raku.
yeah. So what's happening first is to yeah. You wanted to add something,
No, no, no. I'm sorry.
Jeannie?
I kind of thinking out loud. I'm listening.
Okay. So yeah. So what is causing the disturbance? What happens? Okay, there's a phenomena with the sun. When the sunlight emits itself, it's got something called Parker circle. Parker circle is the light when it is the plasma that moves away from the sun, and it's like in a vortex. It's going like a vortex in all different direction. Okay, this is what's happening when the sun, when it's emitting light, normal light. Okay, you get what I'm saying?
Mm-hmm. I'm with you.
So okay, so what happens depending on the position of the sun and the moon and their orbit and their heights? What happens is this vortex is kind of, there are like sometimes it hides, sometimes it uncovers, sometimes it exposes. You understand me what's happening? So it's
Right.
creating that distortion, and depending on the days, it just shows you some part of the sun. So that's how the phases goes too. There are two things in are in function here: the movements, the heights, their angles, and these vortexes with the electromagnetic energy. So what I'm you get what I'm trying to say. So it's
Yeah, this is great. I didn't know all of these things combined together. Never thought of it. The height is really great because that's what's offering the different phases, different amounts of the distance to the charge, the amount that it's able to accept or give a charge. It's cool.
yeah. So if if you wanna give to the viewers a brief of what we spoke, because I was just trying to explain what you understood about the lights and the phases a little bit. What did you
Yeah,
understand?
yeah. It's basically that um, the moon gets the charge, which causes the light in the circuit of the sun, and the angle from which they related, the angle, the height, distance, because the heights change. And so you say it's like in a spiraling cone of sorts. and the different heights will give you the different phases of the moon because of the distance in relation to each other, distance and angle.
Exactly. And this vortex, the plasma vortex of the sun, that is because I don't have the diagram to show you. It's like from the sun, it's like when we see how do we uh, when we see in the sea those crepuscular rays when the
Mm-hmm.
sun is between the clouds, so you see
Mm-hmm.
the beams coming in different ways. So imagine that kind of a beam. It's like it's affecting and it's blocking the light, and that's why that frequency of light of you of the moon, as we spoke about before, it's creating distortion and not showing, it's not glowing that part. That's why it's on that face. You getting it right now?
Think so. Beautiful. So we all got the same distortion then. It's in between the two. It's just not a visual. It's a physical reaction.
Yeah, it's the
Even though
reaction of the yeah, it's the reaction of the two different lights also in a way, and their positions and their heights and their angles. And the most important are those vortexes of the sun, the plasma that is creating and is showing. Sometimes it's uncovering, sometimes it's covering, sometimes it's, so that's why you have that different phases. So I don't know what the general the general traditional science bullshit is about the phases of the moon. We which we know it doesn't make sense. So this is what the real flat earth model phases happens
nah,
with the
just
moon.
a ball on a ball should be enough. I'm sorry.
No, go ahead.
I think um, the ball on the video of the shadows on the ball
Yeah.
should be really compelling for people because it just doesn't match. And I would question anyone who could, I'd like to have someone say something about that. Anybody got any comments on what we really see versus what we've just been told and what we have always been told? This makes it makes so much more sense, Vika.
Oh yeah, all this all the information, it's not the usual dogmatic views what we have about the sun and the moon and the eclipses. Even in the flat earth community, there are so many different opinions. And
Yeah.
but what really are you seeing? What is really happening? So we have to be open for different kind of speculation, but this speculation is really based on a lot of investigation. So it's nothing just speculating from the air, because we have listened to many different opinions and speculations and theories about what could be happening. So this is one more for the people to go and look into and research by themselves and see if it really does it make sense or no, what we are seeing, what is happening. So to put in what we try to make people understand is this, that the light is very important. We saw that it auto illuminate, but it's still depending on the sun for that UV radiation for it to illuminate. So once it's illuminating, and once they are on their trajectory and their height and angle, depending on that, and the plasma from the sun also blocks again, and that's why it's blocking. So we understand the two concept of the two different things, which is really important for us to understand what is happening with the eclipses, because you see an eclipse and a phase is not much of difference, right, Jeannie?
No, it's not. It's more
The
sudden,
eclipse, yeah, the eclipse is more sudden, and
quick. It's abrupt and
yeah,
mysterious. And you know what it kind of
and
reminds me of is people might be able to relate to charging their phones wirelessly. Well, the closer you get to that, you got to nestle that phone right in that cradle, kind of. It has to be very close. Just similar analogy of it to me, or like a remote control. If it has a range where you'll be able to change the channel, I guess, the most efficiently, right?
Right, right.
Well, it's
And
a
ma-
little different,
and
but
also the people speak about Rahu and Ketu and many
yes,
different cosmological. They say there are different celestial bodies that has been covering the moon. It looks like there is something else, but it's not a celestial object. It's just different distortions that we're gonna get into it with the
okay,
eclipses. But it's to understand that it's not something else, another body like sun or moon, which is covering the sun and the moon. Because if you really see in the eclipses, you see that even the behind part of the sky is dark. Why should the behind part of the sun should be dark, or the moon? Because
right,
if it's something in the front that is really making that cover, right?
right, yeah. No, you're right. Yeah, because the sun is behind it supposedly, and the whole in an explosion 13 billion years ago, we ended up with the sun being 400 times bigger and 400 times further away, so they appear to be the same size according to the narrative. And last I heard, explosions destroy things; they don't create things.
Right.
Not this, yeah. This, and in Genesis it talks about the four lights that were put in the firmament. Right, daylight came first, and I think not great with this, but then there was the sun and the moon, and then the stars, and there's seven
Right.
layers to the firmament. So this is what I'm kind of relating it to. That's where the light is, I guess, come in. Is that right, Vika? Where when the height differences between the sun and the moon, is it in a different layer of the firmament? Maybe.
Yeah, they're supposed to be in their own layer, but they do move, like they do move in a
Okay.
way that it looks like they are, because they could interact, their orbit could meet in different points. That's why they call, in the traditional science, they call it the nodes, and that's why the eclipses are
Mm,
happening, because they're
okay.
intersecting to their each other orbit.
Right.
That's what the
Right.
traditional science is saying.
Mm-hmm. Right.
Yeah,
Yeah,
but
and that's why some of them are like, "Wow, it only happens 100 years." I can tell you what. In the '90s, I was working in the city right near the Museum of Natural History where Neil deGrasse Tyson works, and there was a solar eclipse, 80% or whatever. It was in '92 or something, and I looked right at the sun. I had to try. Had to. It's no big deal.
right, yeah, and even with the eclipse with the sun, yeah, we know that it's not the moon. So whatever the mainstream media is telling us about the eclipses and the phases is totally false. It's totally a lie. It's so
Yeah.
easy for them to tell the shit. We have seen the sun and the moon in the same time, and the eclipse is happening, and the Earth is
Yeah.
not there even in the middle.
Yeah. How do you get a half a moon in the middle of the day? Get out
Yeah,
of
and
here.
and normally, if it's the moon, we should see the moon before the sun eclipse. We should see the moon going in front of the sun. Nothing that just something black is coming. It doesn't
Right,
make
right,
sense.
right. Yeah, exactly. I don't know. I remember must have been third grade. The teacher telling us, "Oh, yeah, you can't see the moon during the day." And now I question it. I'm like, did she really say that? Is this like a false memory they planted in my head or something? I thought she really said it because the whole scenario was her saying that, and then I went out to lunch and looked at the moon during the day, and I'm like, she just told me I'm not supposed to be able to see this thing, and it's right there.
Yeah.
And I was kind of scared to go in. I was in Catholic school. I was afraid to go in there and tell her anything. You kidding? They got beat on Tuesdays because Wednesday was coming. So I never I wouldn't confront any teacher in that place, but I might have said it to one of the Boy Scouts or whatever. What is that? Why did she say that? That I would have done. But that always stuck with me. And I don't think it's a false memory because what, so I've thought about that plenty of times through the years. Was she mistaken? I guess, she probably never thought of it. They taught her too.
What I wanted to add, Jeannie, you're breaking up, so
Oh,
I didn't hear
sorry.
you what you say in the last part. So what I wanted to add to also, that we have to see that only with the one with the shadow, we are more or less sure that the moon is more like a disk than a sphere, right?
Yeah.
So
Yeah, that's
the same, and yeah. So if it's that's happening because of the eclipse and because of the phases, we can see that the same thing is happening with the sun during an eclipse. So what we mean to say that it's another dish too. It's not a sphere, right there, without even going there to the sun or the moon, right? How the shadow falls on the moon on the eclipse, it falls exactly the same on the sun.
hmm,
So we are in a way saying that the sun and the moon are a disk formed. It's not
appears to be.
sphere.
No, it's no, it's not a sphere, and I don't know if it's even really physical either. I don't think it's a physical thing. You couldn't land
So
on it.
yeah, so you imagine what you were saying. So also yeah, when they are on different like different tropics and on different heights, and
Hmm.
imagine the two being a disk, and the both of their light and the UV radiation and all these things functioning. So it all, you know
Hmm. And
the concept
also
is,
that
yeah.
hmm,
Go ahead.
um the sun offers the hot light and the moon offers the cooler light, and it's the female light, right? And the sun is the male light. Is that right? And
It's supposed to be, but it's not. The moon is supposed to be a warmer, no? So like warmer in the shade, and yeah,
right,
because it's different
it's
frequency
opposite.
lights. Yeah, it's different frequency lights, and the sun really doesn't have nothing to do with the heat. The sun is supposed to be electric. The sun is supposed to be cold. That's why when we are above in a plane at 35,000 feet, it's cold, it's not hot. What
Yeah.
the heat is produced in the lower, yeah, the heat is happening only in the lower atmosphere.
Right.
Okay.
The heat. I think the
That's
heat
why,
is
because
produced
that's why when we
when it
go in a,
isn't the heat really mostly produced after it bounces off of
yeah,
something.
no, the heat and the light is a very local phenomena. Okay.
Uh-huh.
Very local phenomena,
Okay.
because it's the particles are vibrating and creating that light and heat, and that's why it's local. That's why when we go in a high altitude balloon, we see the light below and the dark sky above, because
Hmm.
it's much, that phenomenon is happening much lower. So the
Right.
daylight is created because of that thing that is happening between the sun and the atmosphere, and all the particles and everything's vibrating, so, and the
Okay.
electromagnetic and the ions, so it's that effect. I have a whole video on that too, if anybody wants to watch Electric Sun on Flat Earth,
I
where
think
it
I've seen that one.
explains. Yeah. So so the daylight in itself is totally independent, so
It is.
anyway.
You could tell
Yeah.
that on a cloudy day too, because when it's so cloudy in a day in July, let's say when it should be full sun, it could still be 100 degrees and raining or whatever, but you don't get any sunlight through those clouds when it's like thunderstorms and heavy clouds. You get daylight, not sunlight. Big difference, huge difference.
Yeah.
And the daylight, in the daylight without the sun, you don't get the same kind of shadows. It's very hard to produce a shadow. Like, under a car, yeah, you'll have a shadow, but that's, a foot off the ground, with a 10 by 15 coverage of a foot off the ground. That's kind of, the shadows you'll get.
Right.
But grass, trees, poles, houses, they don't really leave shadows. It's very interesting to watch. You know, so it shows how it's completely different. The daylight and sunlight and moonlight is fun because, like you said, this is stuff you can really do yourself, and it doesn't line up with the textbooks.
Right. Yep. So we'll continue with maybe because we don't have many guests, so we are going directly
Yeah.
to the topic. So maybe we're not going to be having a very long show today, but yeah, we're going to try to cover what we wanted to speak about today. So we
Mhm.
don't have many different opinions today from the people, but yeah, we are right on the go with what we wanted to. So
These are great videos in the background too,
we'll
Vika.
continue.
They're very cool. I've done the ball
Which one?
experiment. I've done the ball experiment when I first heard of this. I don't know how long ago, years ago, and
Oh yeah,
it's
anybody
just
anybody can
great.
do this. Yep.
Yeah, everybody. I would suggest go try it for yourselves, guys, just so you really experience it. It's the best teacher. It really is. You could watch these all day, but go do it. It might tell you something different in your mind.
Oh
Use
yeah.
whatever you want for the shadow too. Your hand, plate, cup, ball, scissor, anything, whatever. Have fun.
Oh yeah. There's anybody can do these small experiments and try yourself and show it to the people. Yeah, the globals are gonna laugh because these small things, this small experiment, destroys their globe. So
Yeah, I really, really agree with that. I can't agree with that more. And I would love to see anyone in the audience come back with some feedback with their own presentation of what's going on here. This is a really good one. Another one to show people. Like that's not what we're looking at. It's not what you're looking at. Sorry guys, but and it's another great thing is how the moon. I don't know what you feel the view is, but at any given point you can look at the moon shining light through a certain patch of clouds. Very local.
right. Yep.
Yeah.
And the sizes also changes, this depending on the perspective where you are. When it's rising, you see much more bigger, and when it's 90 degree, it's just the same size as the sun when we see. And when it's setting, it's much more bigger, or it's orange. And because
Right.
again, the 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 light playing tricks, you see different colors, sometimes you see a little bit, so yeah, we're gonna get into also why we see it red, why just before the eclipse, why we see this moon red.
Yeah, I'm curious about that.
Coolio. So we're gonna take a short break and we're gonna jump into our eclipse part, all right? And
Excellent, bro.
then a short break and then we're gonna be back. Ran Stop screen. PC trailer one.
There is nothing you cannot be, there's nothing you cannot do, there's nothing you cannot have. You are the most magnificent, the most remarkable, the most splendid being God has ever created. Who could reject such wondrous magnificence? But you do not know who you are. And you think you are a great deal less. I tell you this, you are your own rule maker. You set the guidelines. And you decide how well you have done, how well you are doing. For you are the one who's decided who and what you really are, and who you want to be. The process of creation starts with thought, an idea, conception, visualization. Everything you see was once someone's idea. Nothing exists in your world that did not first exist as pure thought. Next comes the word. Everything you say is a thought expressed. It is creative and sends forth creative energy into the universe. Next comes action. Actions are words moving. Words are thoughts expressed. Thoughts are ideas. Go first to your highest thought about yourself. Imagine the you that you would be if you lived that thought every day. Imagine what you would think, do, and say, and how you would respond to what others do and say. This whole process is a massive move to consciousness. What you will find out if you undertake this challenge is that you've spent half your life unconscious. That is to say, unaware on a conscious level of what you are choosing in the way of thoughts, words, and deeds until you experience the aftermath of them. Then when you experience these results, you deny that your thoughts, words, and deeds had anything to do with them.
I want to remind you to continue to dream and dream big.
All right, guys, welcome back to the show. I'm gonna say give shout out to our viewers here. We got Dr. Frankenstein.
All
We
right.
got we got Flat Earth Nation. That is Carl Fletcher. Hey, brother,
Very cool.
big hello to you. And we got Mike Zudnich says hello, Wika and Jeannie and everyone in chat.
How you
Then we
doing?
then we've got DN. And then we got J Daddy who says, yes, Vika, it's self luminous. Yes, definitely it is. And we explained why it's self luminous because of this UV radiation and how it charges itself and illuminates in the dark, same as when we on a fluorescent in a UV light. Awesome, J Daddy, great to have you. And then we got OG03, and then we've got
Great crowd.
Oh, we got a super chat from Carl. Thank you, brother, so much for the super chat. It really helps to keep the show going. And then we've got Cindy Holland. Then we've got Phil Indel Blank says if
That's
there's an
great.
object obstructing shape, it has to be somewhat close to it or what is projecting it. Okay, we'll get back to you. Is the speaker with a possible Argentinian accent, Vika? Nope. Then we've got who else we got? There's so many other Phillies have so many comments here. Then Hydro Genie says something too. It says 01 object light in the sky have weight. Okay, here is the light in the sky have weight. So many questions about the two object lights in the sky have no weight. So where come from this light? North Pole perhaps or above. We'll get into it. And then we also have Mark Hollander in the chat. Hey, Mark.
Congratulations to Mark. I saw today what happened. But, he's got some great stuff coming along.
Yeah.
Yeah, very cool.
Big hello to you, Mark. And then we've got Sean Hawkins. But we do understand this the moon, the sun, and the stars. What intelligent people do. All right. And yeah, big hello to Cindy too. And what is saying? Is he
Yeah,
talking about
hi.
the moon? The moon is not self-illuminated. It reflects the light from the sun. Okay, Sean Hawkins says, is he talking about the moon? The moon is not self-illuminated. It reflects the light from the sun.
From reflecting from what though? Like the ocean or the atmosphere? How is that? I forgot. The ocean, isn't it?
Yeah, because sometimes it's not even close to
Yeah,
in a line, and it's still illuminating. How is it reflecting?
yeah.
It's bouncing, as you say. Is it bouncing off something else?
Radar. And here's something. Um, the inverse square law of light kind of prevents sunlight, wouldn't it? I don't know. Maybe not, but it
Yeah,
prevents
and the
starlight.
yeah, and it's, we can see that it's not the same light. The reflected light, it's not the same light.
Oh,
If it's reflected, it's, you could see that, there's a difference between the sunlight, when you measure it, everything what it is, and when you do with the moon, it's totally different. And even with the light, the spectrum and the frequency has to be different too. So, that's why we see that
right,
different color.
right. And here's something else. When you see the moon during the day, it does. I could be wrong, but like positioning would have everything to do with it. But how can the sun be behind the moon, light in the front side of the moon, where we see it? So it goes from us to the moon to the sun in positioning. How can it light the front side? How can something behind it light the front side of something that we
Yeah,
watch? I don't understand that. I would love an explanation, not from anybody.
yeah. Okay, so yeah, so we're gonna just give a small brief of what we spoke about in the first half of the show, that we are discussing eclipses. So for understanding eclipses, we were trying to understand what the moon is, and how, what it is, what light it is. Is it reflecting, or it's self-illuminating? We explained it is self-illuminating because of the radiation from the sun. The moon needs the UV radiation for it to illuminate itself. Okay, it's not illuminating the sunlight. It's illuminating, as I said before. It's just charging itself
Charge.
to that UV radiation, and when it's dark, it just emits its light. That's, we have to understand well before we understand the eclipses. Okay, so,
And the
and we
height
also spoke
differences give the height differences
exactly
give a different charge, and that's what offers the different phases of the moon.
right,
Okay.
right. The different angles, the different height in
Right,
their
the angle as
orbit.
well.
Yeah, and the vortex of the Parker circle of the sun, as we explained, also blocks and uncovers or covers part of the light. So it's just the two or different thing that's happening in that time, that is distorting and creating that fixed phases. Okay, so we
Hmm.
understood that two things, what's happening. Okay, now we come to the eclipses. What happens during the eclipses, the moon eclipses? Okay, and eclipses mostly happen during a full moon, because it's when it's 180, and when it's at the same height. Okay, so when this is happening between the two light, the sunlight emitting is sunlight, and the moonlight emitting is moonlight. Okay, so it's kind of full charge, there is no disturbance of anything. That's why the moon is full. All right, because it was also there in right in the front at 180 degrees, no? So that's why you have the full moon. So what's happening, what's the distortion? There have to be something in the middle that is creating that another kind of distortion. So what is happening? Okay, at the north pole, we are supposed to have the column of the electromagnetic field column, where even all the compasses points to. We all know that, we don't need to prove that there's an
Right.
electromagnetic energy column in the middle, which we also call Mount Meru. Okay, in
Hmm.
cosmologies, in different cosmologies, and maybe in science they call it something else, the dark tower, or there are different ways to put it out there. But what it is that column of electromagnetic energy in the middle. So what's happening there during an eclipse of the moon? What's happening in that moment? So what happens is the sun and the moon, they both, when they emit light, they are polarized. The angles are a little polarized. So what happens is that the light of the sun and the moon is getting distorted because of that column. We have to understand the Faraday effect. What is Faraday effect? Whenever you put electromagnetic fields to a light, it distorts the light. So what is happening is that the when it's at the same height, the light of the sun going through the magnetic field through that Faraday effect and the angles, and it creates also another distortion. So here is what is happening. The difference is the Mount Meru is in the middle, okay, of the sun and the moon in that time of in that position, in that angle, in that height. Okay,
And you
that's
said that's
why.
what a full moon.
Yeah,
Right. So the full moon always rises at sunset. 180. That's right. Yeah. Perfect.
right. So what's happening? So this polarization of these two lights is is kind of projecting that distortion on the moon because of the light interference. You get what I'm saying? So it's instead of the phase, it's just hiding the whole moon for some time. Okay, so what's happening, the light of the moon also have a speed. Okay, so during that effect of the sun coming through to that column, it's slowing down the light of that frequency of the moon. That's why it turns red first and then it goes black.
Mm. So
And then
it's
again
just
it's just after it passes through that position, again it just clears up. I don't know how to put it in the word. I hope the people understand. My English is not the most perfect, guys. Sorry, but I'm
no,
trying to put in word. So I don't know if you
that's
could, if
great.
you can make it, if you would try to put it in your own word, Jeannie, what you understood, what I'm trying to say, till I can add back.
I'm drawing a blank right now.
It's quite
A
complicated, yeah.
little bit. Yeah. Yeah. I'm still going over the last stuff. Yeah. I wouldn't know how to repeat that right now.
Okay,
Um.
we have to understand the Faraday effect. What is the Faraday effect? Faraday effect is you can do an experiment in a lab in a small, like you put electromagnetic field around a light and it creates distortion. It creates polarization of that light. It
Okay.
changes the angle. It changes the angle. It changes. You get what I'm saying? That is Faraday
Right.
effect. So what's happening during an eclipse is the same thing. The light of the sun that is falling through that column is polarizing the angle and putting reflecting it on the sun, on the moon,
Okay.
and that's what's creating, and it's just lowers the speed of the light and the free that fluorescent light, that fluorescent UV light, it decreases, it becomes red, and then it blocks totally, and then it clears up. And that's all happening to that column, that central column on the North Pole, Mount Meru. Okay, there is nothing, no object, there is no another celestial body, there is nothing. There is just the sun and the moon that are moving around at the north
Right.
in the center, and that's what's happening because of Mount Meru in the middle.
Wow.
No traditional or mainstream science is going to tell you this. That's what is actually happening. Even in the flat earthers, they have a different opinion about what is really happening with the eclipses, with the Rahu and Ketu. These are symbolic names, just to put names. Okay, or
Right.
in another culture, they're saying is the wolf that is eating the sun. Is another cosmology, is the way of saying why the eclipse
Okay.
is happening. But this is what is happening in reality. That even many flat earthers don't know what is causing the eclipses.
That's great. That's incredible. So it's just an effect of magnetism, then. Is that right?
Yeah, so it's all light and effect of magnetism
Yeah.
and their movements and their heights and their angles and so it's all light and light distortion to different ways. The ones we saw in the phases was through the parallel circle, the plasma from the sun that is rotating, that is which is blocking and unblocking and that's why we have the phase. And in the eclipses we have the Faraday effect that is happening to the central column of the electromagnetic field from the center of the earth, that is blocking and creating that polarity of angles of the sunlight and the moon and reflecting on that. And that's why we have that, and that's why it looks like a phase, but it goes quite, not fast, but it's quite, you know, that's why it
Right.
goes red, then it goes full black, and then it goes red, and then it clears up because of these things happening in that moment, in that time. And all is very predictable. Okay, all the eclipses are very predictable because of the movement of the sun and the moon and what's happening.
Hmm. You know, it makes me wonder, maybe a little offbeat again, but why the Vatican is so interested in the movement of the sun and stars and moon. They have an extreme interest in all of that stuff, which is kind of suspicious.
Oh yeah, oh yeah.
So,
I wanted to say to Carl Fletcher. Yeah, yeah, Carl. I saw the image you sent me on Messenger. Yeah, it's awesome. It's an eclipse. It's awesome, brother. So I hope the people get what we are trying what we are trying to present here. You know, as I say, it's not put in the most perfect way, but I hope the people get what we are trying to say here. What's really happening? It's all about different lights and their position and the, you know, I put it already there. It's for the people to ponder and may do their own research and come up with their own conclusions. You know, there is, it's nothing in the middle, it's nothing in the middle, a celestial body, it's nothing. You know, it's just the two different lights and the electromagnetic energy and all these different effects that is creating all this process of the sun, the moon, and the two being the disk. You know, it all makes sense of
and
that
and
polarization and the angles. Yeah, go ahead.
they are reproducible, and you can observe these little experiments yourself.
Right, right. Henry
Yeah.
Autumn says Rahu and Ketu. Yeah, Rahu and Ketu is a way of saying it, but there are no any black or invisible or black sun or whatever you want to call it that is moving like the sun and the moon in the sky. It's nothing like that.
So if the sun charges the moon, where's the sun getting the energy from? I wonder.
But if the sun is
It's just,
light is
is it?
radiation, is different
Mm-hmm.
kind of radiation. All
Mm-hmm.
yeah. So one of the 70% part of the sun produces UV radiation. So that's where it's getting, the moon is getting that energy from to give it back. As I explained in the fluorescent thing, you know,
Uh,
that the
I missed.
fluorescent paint is glowing because in the UV light,
Right.
or even in the UV light, it glows really strong. But a fluorescent stuff, anything fluorescent, even without UV light, it can illuminate a little bit, you know, even
Mm-hmm.
without any
Right.
light, because it has that, because it's storing that energy to put it back, because the had that properties, could be synthetic, could be organic, could be biological. It's just a
Right.
different way, minerals. So we don't know exactly what material is the moon, but it's
Right.
functioning in that way, you know.
That reminds me of, like, we don't have, God doesn't have to adhere to our rules, and we can find out new stuff that He did all the time. It's
Oh
magical.
yeah,
This place is awesome.
yeah, because somebody was also asking before about the tides, what create the tides. Yeah, I also have another video about that, but I'm gonna give a quick it's the electro is again the electromagnetic energies.
Yeah.
Everything, the earth has its own electromagnetic energy, the sun and the moon has their own electromagnetic energy. Okay, so the earth, the water being diamagnetic, it pulls or retracts depending on on the positive energy of the sun and the negative energy of the moon. That's why you have that pull and push effect between the sun and the moon and the electromagnetic energy of the earth. That's why we have tides. I have a whole video on that. It's called Electric Sun on Flat Earth if you want to check it out. So, yep. Anybody have any more questions? Because soon we'll be wrapping up because our presentation was small. If we had more people, we would have had more opinion and more to discuss. But we have already put it out there. If people want to know what's really happening, you know,
That's
with
that's
those.
that's great information, Vika. It made a lot of sense to me. I have to go over it again and really kind of be able to say it better. It makes sense. It makes a lot of sense. The height difference is spiraling. Hey, let me ask you something. If there's a height difference, would that be a size difference also? Because they always look sort of the same size, right? So
Yeah,
do they?
they look same size
Mm-hmm.
from our perspective. Okay, but if you
Mm-hmm.
really see a high altitude balloon, if you see on a high altitude balloon, you see the sun very close and you see the moon very high, very far. You'll never see the same size. Go
Hmm.
and see on a high altitude balloon and see the sun and the moon. You're
I
never gonna
have,
see the
yeah.
same size.
I didn't pick that up though. They're not the same size, but you can see them and they're kind of eye level. Those 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 balloon the amateur balloon videos are really cool.
Yeah, yeah. Jay Daddy said my greatest teacher spoke with an accent. It's makes it better in some mysterious way. No worries, brother. Awesome, Jay Daddy. Awesome.
100%, Jay. Absolutely, Vika. Wonderful presentation.
Oh yeah, so yeah, people, there you have it. Why is the eclipse happening? So it's nothing in the middle there, no celestial body. It's all about the light. It's all about the electromagnetic energy. It's all about how the light reflects from the sun and how it illuminates, how it creates the phases, and how the eclipse happened to the column and all the Faraday effect on the Parker circle. Everything is right there for people to look into and make up their own mind, guys. So thank you everyone for passing by, and especially everyone who join us always. So thank you so much, and especially Jay Daddy, who else is there, who always join us. Yeah, Flat Earth Nation, Hydrogenie, and Cindy, and yep. So thank you guys, and I hope you had a great time. We don't. Yeah, Jeannie, do you want to add something before we sign off?
Sure. Thanks for the invite, Vika. That was a great presentation. Your accent is awesome, brother. And mine might be worse than yours, if anything.
We
Mm,
try. We, we try to do our best. Yeah. So yeah.
oh man, that's so much food for thought. Yeah, honestly, I got stuck on the second half because I was like, wow, at the first half. But it's really interesting, and hopefully everyone in the audience had a nice time tonight. Thanks for joining us on a beautiful Sunday. It's good to see everybody. There's a really great crowd out there, and Vico, we'll see you next week, my brother. I hope your weather's holding up. It just started pouring out here,
All
flooding.
right.
Yes.
Yeah,
Yeah.
yeah, for sure. We had even the last week show was awesome. We had an amazing presentation, and even this week,
Yes.
yeah, it wasn't very long. Yeah, we are maybe 20 minutes short of the our normal time, but yeah, that this was also quite a good presentation. Yeah, the information is more important, you know, than
Yes.
the way it's been put out sometime.
Ah, it's a great it's a great personal observation for everybody. A lot of these things you can go do yourself. almost any night, and really solidify what your thoughts are about these things that are misrepresented by the establishment. You know?
Oh yeah. Oh yeah.
Yeah, yeah, and it's yeah. That was really, Vic. I had a great time tonight. That was awesome. Very cool.
We'll do our best. We're gonna always try to, if we do shows like this where we are doing screen sharing and we are doing some presentation, make sure guys we're
Yeah.
gonna get you things that as it's not just so, usual stuff. We always gonna have stuff which could come out in the near future, but we are gonna bring it as soon as we can
Mm.
and when we see, so yep. So make sure you always join us on Heliopsychosis podcast. And a really special thanks to everyone who has joined us today and to the
Yeah.
ones
Thank you,
who
everybody.
always join us. So thank you, Jeannie, for joining and being with me today. And yes, finally, it was an awesome show.
Yeah, yeah. Hiccup in the beginning, but that's okay. Thank you for having me, Vika. I'm always looking forward. I really am. It's great stuff. Crushing the globe, guys. Thanks for being here, everybody. Enjoy your Sunday, and hopefully we'll see you next week.
All right, because yeah, just an announcement. Maybe the next week's show won't be on Sunday. It will be on Friday because we have some guests and we couldn't make it on Sunday, and me too myself because got things to do. So next week's show is gonna be on Fridays,
Excellent.
and we have an amazing guest coming. So make sure you guys, and that's a surprise. So make sure you guys check us out next week. All right. Thank you guys.
Good night, everybody.
See you everyone. This is Vikka Draziv signing out from Heliopsychosis podcast. Bye everyone. Bye.
I'll see you, brother. Hey, bro.